Welcome back, my dear students. In this class, we will derive an expression for normal stress and shear stress acting on a two-dimensional element. Okay? I think you didn't understand, right, what I told. Don't worry, I will explain it. See, in the last class, we studied three-dimensional body, how it looks, and what all stresses will be acting on the three-dimensional body. And after that, for you people are very small kids in civil engineering. That's why we reduced it to two-dimensional stress system. In two-dimensional stress system, there are two types. One is a plane stress theory and a plane strain theory. Then now I will concentrate on plane stress theory. Plane strain theory, I will not concentrate on you because it is not included that much in the theory. Therefore, we will concentrate only on plane stress theory. Plane stress theory. Okay. Now, I will consider one plane. This is one plane. Perpendicular to paper is 1, means unit. That I don't draw. Now, if I apply some stress here, that is called as sigma x. And if I apply some stress here, that is called as sigma x. And these must be equal so that the body is in equilibrium. Now, if I apply some stress here, sigma y, then I have to apply some stress here, that is called as sigma y. And these two stresses must be equal and opposite. Sigma z perpendicular to the plane is considered 0 because this is plane stress theory. Okay, now apart from that, there will be some shear stresses acting. This I will consider shear stress. This value is tau xy. Then here the shear stress will be acting. This value will be tau xy. Because this is applied, this generated, both must be same. Then now the body is not in equilibrium. Why? Because this is rotating. To stop that, I have to apply counter rotation. This is complementary shear. This value will be tau yx. Then here opposite to that direction, tau yx. But tau xy must be equal to tau yx, then only the body is in equilibrium. Now the entire body is in equilibrium. No doubt. Okay. Now, how to prove it? Prove it that the body is in equilibrium. How to prove it? Just the answer is very simple. The answer is by having the equation sigma fx equal to 0, sigma fy equal to 0. Right? I should have sigma fx equal to 0, sigma fy equal to 0. Then what about z? Not required. Mz. Summation of moment not required because this is considered one point and all forces are acting at a point. Therefore, it is enough to consider sigma fx equal to 0, sigma fy equal to 0. If these two are proved, then the body is in equilibrium. Okay, now sigma fx equal to 0, look at here. Sigma x equal and opposite cancelled. Tau xy, this cancelled. Therefore, sigma fx equal to 0. Sigma fy equal to 0, sigma fy cancelled, equal and opposite. Tau xy and tau yx and tau yx, these two are equal and opposite, cancelled. Therefore, it is in equilibrium. No doubt. Now I proved that the body is in equilibrium. After applying these many stresses, inside this body, there will be some stress induced. I am telling it very slowly because you need to digest it. When I stretch up particular paper like this in this manner, then there will be some stress induced in it. Some resistance will be there in the body. That how much resistance is there, that I have to check it. Let us consider this. I will make myself big. I'm very proud of myself. See, I made myself big. See here, this is a plane. I am applying some force this side and I am applying some force this side, both equal and opposite. And some person is applying force this direction. Someone is rubbing, someone is rubbing, someone is rubbing here, someone is rubbing here, like that. There are 4 types of shear stresses and 4 normal stresses are acting. Now when I apply this force and this force, it will break. Let us apply, but no one is there here. Don't worry. Here God will pull. Here some other devil will pull. Right? Then we'll apply it and we'll break it. Right. Now it's broken. Now this is there. No, this is randomly because I randomly applied it. Therefore, it happened like this. This I will call it as a plane of interest. That I will call a plane of interest. But actually it is a failure plane. Just now what I think is, if I draw one line or one plane it is with some angle theta. This is one plane. At this plane, how much and which type of stresses will be acting, that I need to see. See here, this paper, if I zoom this one, if I zoom this part, now look at here, this paper has broken like this. At this point, if I zoom and put in a microscope, then I will observe something like this. See, these 2 papers, if I put in a microscope and observe, I will see something like this and something like this. It indicates that the paper is not cut exactly like this. It is not cut exactly like this. And it is not cut exactly parallel, but it is made some inclination. It indicates that there is shear stress also induced, there is normal stress also induced. Both are induced, normal stress and shear stress, both are induced. That is the indication. And one more thing, when you tear the paper, you will observe some sliding sound. This sound you will observe. That is because of shear stress induced. Some rubbing action will be there between the 2 papers. Normal stress, how you will observe? Cut. I don't have any pencil here, pencil or otherwise that chalk piece. When you pull the chalk piece, when you bend the chalk piece, you will see the word sound cut. When that cut comes, there normal stress only it is induced. Then when stress that sound comes, then there will be some shear. Therefore, when I pull this, then again means some shear will be there. From this, what I would like to convey you people is, when we apply some amount of stresses here, when we apply lot of stresses here, then there will be 2 type of stress developed on the surface. Those 2 type of stresses I can show them as one, I will call it this as a normal stress, and another will be some shear stress will be acting. This is acting on the interested plane. This I will call sigma theta and this I will call tau theta. Now I want the expression for sigma theta and tau theta over. This is what the derivation is. Sigma theta and tau theta I need to get. Any doubts? No doubts. Thank you. Now we'll go. Put the heading, derive an expression for, write down, derive an expression for normal stress and shear stress, normal stress and shear stress on the plane, with an angle theta with respect to vertical axis when general stress system is acting on the plane. Here, what is the meaning of general stress system? The word here is general stress system. General stress system means shear stress, normal stress, both are acting. You can call this figure, whatever I drawn here, this is a general stress system, because all type of stresses are there in the figure, right? Now here, before going to derive, I am going to analyze, I am going to make some points. That points you need to by heart, then only the derivation is possible. In later classes when we solve the problem, these points must be very important and you need to remember them. Then only you can use the concept, that derivation. Okay, prerequisite we can call. The first prerequisite is sigma x is greater than sigma y. Very important. Here, whenever the problem is given, you need to observe that sigma x must be greater value than the sigma y value. Then only you can use the derived equation. Means while deriving, I am making these assumptions, these very important assumptions I am making. Sigma x is greater than sigma y. And the second thing is sigma x is in tension. In the figure it is shown sigma x is in tension. Then I will consider sigma x value as positive value. Okay, what happens if a sigma x value is in compression? Then that value I will consider it as a negative value. Sign convention. Like that. Third one is sigma y value is also in tension. If it is a tension, I will consider it as a positive value. If it is a compression, I will consider it as a negative value. Okay, now. Then fourth, very most important is shear stress arrows must meet at right top corner. See here, we can have one more diagram, that is, this is a diagram and shear value I can have like this. See, either they have to meet at this point or they have to meet at this point. See here the right top corner, the shear stresses are meeting. Then if this is the case, then I will call it as positive shear. Okay, if they are meeting like this, means if I have a diagram this way, then I will use negative toe values. Okay, now these sign conventions you should know, then only we can go ahead. Very important fifth convention is theta must be with respect to y axis. Theta must be with respect to y axis always. Sir, if it is x axis, then what? Convert it to y axis. You know trigonometry, okay, and you convert that into y axis. And theta must be measured in anti-clockwise direction. Then theta is considered as a positive. Now look at here. This is a one vertical section and this is your plane. Then this is rotated this way. This is anti-clockwise direction rotation. Then it is a positive. This is a positive. If it is in a reverse clockwise direction rotation, that is a negative. These 5 conventions you should know, then only we can go for derivation. Hope you are clear with this. Okay, then we will erase it. Now derivation starts. you can put the heading derivation. Already told, no? Derive an expression for normal stress and shear stress on any oblique plane when an element is subjected to general stress system. Okay, derivation. Some sentences you can write it. Let us consider 2D stress system as shown in the figure. Let sigma theta be the normal stress, tau theta be the shear stress on an oblique plane. Let us consider the point is in equilibrium under sigma y, sigma x and tau xy. You should know these all points. Then we will go ahead. Moscow country. The body after breaking into two parts, that body is again in equilibrium. To prove that, we need to get summation of fx equal to 0, summation of fy equal to 0. What is the meaning of breaking the body into two parts? See here, these forces are pulling this side and these forces are pulling this side. I expect that the body may break. The body may break this way. The body may break this way, right? Yes, it is broken like this. And the top body is like this. Actually, it will break like this. So it will break like this force, this force, this force, this force, this, like that. It is broken like this. That is your XY plane. Okay, now XX plane. Now this is what you got. But here, that I assumed it as a sigma theta, and some shear stress will be acting on this broken plane, that is tau theta. And here you already know this is a sigma x, sigma y, and this is sigma x, and this one is tau xy, and this one, actually this is tau yx, but tau yx equal to x, the xy, therefore I will call this also tau xy. Right? Okay. Very important is, you know, to prove the equilibrium condition, we want summation of fx equal to 0, summation of fy equal to 0. But we don't know forces here. These all are stresses that I want to convert it into force. Therefore, I will mark this as a, this as a B, this as a C. Right? A, B, C. Then this plane is AC and perpendicular distance is 1. Therefore, the area under AC is AC into 1. Like that, BC into 1. Like that, AB into 1. That they are the areas corresponding to AB, BC and AC. Right? Now, what is the meaning of stress? Stress is the force by area. If you want force, then force equal to stress into area. Means for all these stresses, if I multiply area, then they become force. Now, this sigma theta, I need to multiply area AC into 1. That 1 I don't write. Tau theta, I need to multiply the area where it is acting, that is AC, and where this is acting is a BC, where this is acting is a BC, where this is acting is a BC, AB, right? This is acting AB, where this is acting is a AB. Now all the forces are converted in, all the stresses are converted into forces. Okay, now all the stresses are converted into forces. Now I can apply summation of fx equal to 0, summation of fy equal to 0. But here again the theta is very difficult to measure. Here the theta is given, and our concentration is mainly on sigma theta and tau theta. Therefore, what I do, look at here, very important diagram. If you know how to draw this diagram, then everything becomes very easy. Okay. Let me write once again that diagram. Now, this is again difficult to understand. Therefore, what I do, I will draw one more diagram here. First year you are very familiar to solve such problems, no? That type of diagram I am going to draw. This is a x axis, this is a y axis. Okay, now look at here, sigma y is acting downward, sigma y acting downward, sigma y bc. Now this toe actually acting downwards, that toe acting downward, toe AB. Any doubts? These two? No doubt. Thank you. Next, sigma x is acting horizontal. Sigma x is acting horizontal into AB. This toe is acting horizontal. That toe is acting horizontal. Therefore, this is a toe BC. Any doubts? No doubt. Thank you. Now, sigma theta is acting inclined in this direction. This is sigma theta in this direction, AC. No doubt. Now, shear, that one more force is acting in this direction. That force is acting exactly perpendicular to that, this force. This is a toe theta AC. But actually you people know that this is x-axis and this is y-axis. But I don't agree with that. I will take a different x-axis and different y-axis. Why? To help you people, so that the derivation becomes very easy. That's why. Okay, that you think how I made it, how I helped you, that you think later. Now what I do, I will consider x-axis and y-axis in a different direction. They will be, this I will consider x-axis, this I will consider x-axis, means this will be negative x-axis, correct? Negative x-axis. Then what about perpendicular to that? Perpendicular to that, this is y-axis, positive y-axis, and this is negative y-axis, negative y-axis. Any doubts? No doubt. Now my concentration should be on this axis and this axis. Therefore, if you are very confusing how to operate, then you tilt your head like this. Okay, you tilt your head like this and read the diagram. Okay, now look at here, coming to the thetas. This is a theta given. This line, if I extend it like this, here I am getting one triangle. In this triangle, this is a 90 degree. Then this must be 90 minus theta. This must be 90 minus theta. When this is 90 minus theta, see, this is 90 degree now. Wait. When this is 90 minus theta, this is theta. When this is theta with this one, then again this with respect to this is theta. This is theta, means this is theta. Any doubts? That is theta. Okay. Now, if that is theta, then what about this? This is also theta. Then what about this? This is 90 minus theta. 90 minus theta. Right? you should always know. And one more thing, this is theta, this is 90 minus theta. In mechanics, you should always know this theorem, that is, if any force is like this, F, and if this is the angle theta, then F towards the theta is F cos theta, and F away from the theta is F sin theta. F sin theta. That is all depending on the where theta is. Like that, if this is a force like this, then theta is here, then this is a F, then F towards the cos theta, theta is a F cos theta, and F away from the theta is a F sin theta. This you should know. Okay, na? Thinking that you know that, I will go ahead. Okay, don't worry. If you want to write, go back, pause it and go to 10 seconds or 15 seconds back, and you can write it. Now, considering this x-axis and this y-axis, I will write equation for summation of fx equal to 0. Means bring all the forces in x direction and equate to 0. Take this sigma theta into AC is already in x direction, positive x direction. I don't have any doubt. Now, sigma x into AB, I have to resolve it to x axis, then this becomes minus sigma x AB, sigma x AB cos theta. Sigma x AB cos theta. Next, minus tau BC cos theta. Like that, minus this force sigma y, that bring to this side. Okay, sigma y BC cos 90 minus theta means sin theta. Sin theta minus tau AB cos 90 minus theta is sin theta. Now this tau theta into AC is there, no? That is acting on y axis, therefore this I cannot resolve it to x axis, therefore that won't come in this one, therefore equal to 0. You got this one. Now sigma theta AC, that I will keep it this side and send everything that side. Sigma theta AC this side and everything you send that side. A little rearrangement will do it. Rearrangement is sigma terms I will put it one side, sigma x AB cos theta plus sigma y BC sin theta plus tau BC cos theta plus tau AB cos theta. Okay, na? Now what I do, this is equal. Now sigma theta I will keep it as it is, AC I will send it that side, then sigma x AB by AC cos theta plus sigma y BC by AC cos theta, sin theta plus tau BC by AC cos theta plus tau AB by AC cos theta. Okay, na? Next, coming to this diagram, in this diagram define cos theta. Cos theta is adjacent, that is AB, hypotenuse AC. This is A, this is a B, this is C. Like that, define sin theta. Sin theta is BC opposite by AC. Now AB by AC is cos theta, therefore sigma x cos square theta plus BC by AC is sin theta, therefore sigma y sin square theta plus tau BC by AC is cos theta, sorry, sin theta. This is sin theta cos theta, plus tau AB by AC is again cos theta, sorry, sin theta, that is sin theta by here I made a mistake. This is a cos theta, this is a sin theta. No, see, AB के बाजू sin theta, therefore AB के बाजू sin theta. Okay, therefore this is tau AB by AC is a cos theta and sin theta. Okay, now what? In trigonometry, cos square theta can be written as, where I have to write, I don't have a space, here I will write. Cos square theta can be written as 1 minus 1 plus cos 2 theta by 2. Therefore, sigma x 1 minus plus cos 2 theta by 2 plus sigma y, this I can write it as 1 minus cos 2 theta by 2 plus tau taken common, sorry, these two are same, one and the same, therefore 2 sin theta cos theta. Okay, now sigma x I will send inside and sigma y I will send inside, split the bracket and rearrange, you will get sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau 2 sin theta cos theta is sin 2 theta, sin 2 theta. This is equation for sigma theta by heart. Okay, very important equation. Any doubts? No doubt. Thank you. Now we'll go to the second derivation. Pause it and write down. Now we will derive an expression for shear stress on that oblique plane, that is tau theta. That is tau theta. Where is tau theta? Here is the tau theta. Therefore, tau theta that is tau theta is in y direction. That first I will write it. Summation of Fy equal to 0 I want. Summation of Fy equal to 0, in this one tau theta is in a negative direction. Therefore minus tau theta AC, in a y direction only it is purely, therefore that much only. Then these two forces comes to positive y direction. If it is theta, then this is a 90 minus theta, this is 90 minus theta. Then this sigma x AB positive, sigma x AB towards theta is a cos theta, but cos 90 minus theta. Sigma x AB towards the theta is a cos theta, but theta is a 90 minus theta. Therefore, cos 90 minus theta is a sin theta. Sin theta. Next, in the same line, plus tau BC into cos theta, again this is the sin theta. Again this is the sin theta. Next, coming to sigma y will resolve to negative y axis, sigma y BC into, this is a theta, therefore directly it is a cos theta, minus sigma y BC cos theta and minus tau AB cos theta. Okay, this and this sigma theta won't come into y direction, therefore equal to 0. Now we will send this one that side and everyone will be let it be here only, because this is a minus 1. If it goes that side, that becomes positive. Therefore sigma theta AC equal to sigma x AB sin theta plus tau BC sin theta minus sigma y BC cos theta minus tau AB cos theta. Okay, now this AC is there, no? Bring that AC this side. Then what happens? I will alter here only, you write it separately in your notebook. This AC I will remove from here and I will write here. Okay, therefore I will get here AC, here AC, here AC, here AC. Now the same triangle cos theta means AB by AC, sin theta is BC by AC. Therefore sigma theta becomes sigma x. AB by AC is cos theta. This becomes cos theta sin theta plus I will bring this one. So therefore this is the minus sigma y. BC by AC is a sin theta. This becomes sin theta cos theta. Then this one I will write plus tau BC by AC is a sin theta, therefore it is a sin square theta minus tau cos square theta. Okay, now here sigma x minus sigma y, because cos theta sin theta is common, cos theta and sin theta took common, plus tau will let it be here, then this becomes sin square theta minus cos square theta, and here divided by 2 and multiplied by 2, nothing will be change. Therefore this cos theta sin theta into 2 becomes sin 2 theta. Therefore sigma x minus sigma y by 2 into sin 2 theta. Then here sin square theta minus cos square theta, I don't have any equation in trigonometry, but I have an equation for cos square theta minus sin square theta. Therefore minus taken common, then cos square theta minus sin square theta. Therefore again writing sigma x minus sigma y sin 2 theta minus tau cos 2 theta is your tau theta equation. Okay, these two are very important equation. I will put together sigma theta equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau sin 2 theta. Then tau theta equal to sigma x minus sigma y by 2 into sin 2 theta minus tau cos 2 theta. This much is enough for today. Thank you very much.